Christmas, we have this gateway test, and then we have a regular. We're going to get started a little bit in chapter 4 later next week, and then into the week before Christmas. We'll be getting into chapter 4 a little bit. Chapter 3 is fairly short. And we'll have a quiz there on a couple things in chapter 4 right before Christmas. Then you have that extra credit opportunity we talked about with the calculus carols, right? And then there'll be some sort of another homework assignment. I put one daily assignment in, a homework assignment in here last week, I think, and we'll have another small homework assignment probably will go in there at that time. Okay, so those are kind of the grades we have left.
So the final's not till after.
Right, the midterm is not till after Christmas. So we do not, so those of you that will be studying for an AP Chem final and stuff like that, you will not have one of those in this class. So that'll be good. Of this week? If you're gone Thursday, Friday this week, yeah, I mean, we've got this test on Tuesday, so you won't miss too much new, though. I wouldn't think there. The big stuff will be the next couple days. Now, the gateway test, let me just say that one more time, just quickly, we'll talk more later in the week, but you've got 10 questions. You've got to be able to do their derivatives, and so let's just do a couple of examples here. So let's say we were going to say y equals, let's use that Leibniz notation for this example, it's better. But so let's say we wanted to do the derivative of x cubed minus 2x to the fourth. I'm going to do 4 quick examples here. Or let's say I'm not going to write it in this Leibniz notation in the quiz. What I'll do is I'll give you y equals, I'll give you a function, and you're supposed to find y prime. That's the same thing here. Same thing we're talking about. Let's do x cubed plus sine x. Okay. Then we're going to do x cubed times 2x to the fourth. And then we're going to do x cubed times sine x. Now you notice the first two have plus or minus signs in them, the last two have multiplication signs in them, and we're going to talk about the differences today. Now, on the gateway test, what will happen is you'll get 10 problems like this. Now these are way too easy compared to what's going to be on the gateway test. Okay, but you get the idea. You're going to be given a function, you've got to do the derivative. That's it, 10 of those questions. There's no partial credit. You either get it right or you don't get it right. Okay? And you've got to get 8 out of 10. So 8, 9, or 10 right is considered passing. If you pass it the first time, you get 30 out of 30 in the grade. And that's what we'll do on Tuesday. If you don't get 8 out of 10, then you'll have to come in on your own time and take another one. And another one, and another one, until you get 8 out of 10. Now, at some point, you can just take the best grade you get. So the best non-passing grade would be a 7 out of 10. So if you get a 7 out of 10 and can't get to that 8, at some point, you might as well just take that grade, because here's what will happen. The first time, you get 30 out of 30 if you pass it. Then you get 2 tries, and if you pass it on one of those, you get 27 out of 30, which is an A. That's pretty good. I mean, think about that on our other quizzes. 3 chances to get an A. That's not bad, right? So you pass it on one of those next 2 tries, you get an A. 27 out of 30. You get 2 more tries, you get a B. That'd be 24 out of 30. So if you haven't passed it in one of those 5 tries, but let's say you did get a 7, you might as well take that, because now at this point, if you take it and pass it after that, the best you get is a 21 out of 30 anyway, which is a 7 out of 10, right? But if you get to that point, you've taken it 5 times, and the best you got is 3 out of 10. Number 1, you're not trying very hard. And number 2, and then you just decide to give up, because unfortunately that is happening. Then 3 out of 10 is what goes in the grade book. Well, that'd be 9 out of 30 is the grade that we go in the grade book. Okay, now, we do run into a little bit of difficulty with Christmas and the end of the term. Now, I have went in, if somebody comes back after Christmas and passes it, went back and put that grade in, instead of a 9 out of 30 or whatever grade you have that time. Probably what I'll do is we get to Christmas, the end of the term, you haven't passed it yet, your best grade's a 3, I'm going to put in 9 out of 30. And when you come back after Christmas, you can take it again and get a better grade if you pass it, and I'll go back and replace that. Okay? So you want to be pretty diligent about doing that. You know, if you don't pass it next Tuesday, you want to get in the next day or the next day after that and take it. so you have time before Christmas break gets here. Okay? You can only take one a day. We had people come in and they get done with about 6 and they realize they're not going to do it, so they hand it in and then they say, "Can I take another?" No, can't do that. The idea is if you're not passing it, you study some more and you get it figured out, and then you fix what you're doing wrong. So you can take one a day.
So it takes us like a fourth to try to pass it, but we get 100 on that. Can we take the 100? Since that's our best grade.
No, that was not what I said. If you haven't passed it, in your best grade, that's not passing. Okay? So yeah, it doesn't matter if you get 8, 9, or 10, doesn't matter. It's passing. It's either passing or not passing. Okay? So they do get a little easier down the road by the time you get to the 5th, 6th, 7th one. I do take a little pity. Right? And they might get a little bit easier at that point. Okay? But the best thing to do is to study hard and work out this week, because let's face it, this week, this is all we're focusing on. Up through Tuesday, next Tuesday, that's all we're focusing on. After that, we go on to new stuff. So now you're trying to study and pass the gateway test and keep up with the new stuff we're doing too. Okay? So it's not the best scenario. A typical year, somewhere between a fourth to a third, 25 to 30% pass the first time. Okay? So out of 42 people in our 2 classes combined, what's that? 14 would be a third. Right? A fourth would be about 10.
What's the most?
So
we've
10
ever
to
had
14.
someone-
I think we've had close to half,
No, what's the
40
most
some percent.
someone's ever taken?
The most times. Well, I used to not give the option to take your best score. Like if you got 6 out of 10 and you keep getting 6 out of 10. So it either was a 0 or you keep doing. So I think somebody went to like 8. I had somebody go to 8.
That's great.
But break the record. But what I found over the years, I think that's why I went to give it, is people got way too, students seem to get more willing to take that 0. Like they take it 2 times and not pass it and they never come in again, ever. I said, well, you got, not just give me 0. Okay. So then I said, well, so maybe I give you a little more incentive to whatever. So but some people make that choice. I guess that it's not worth the effort, I guess, to study for it and try to pass it, whatever. So I haven't had anybody come close to taking that many cents. It seems like when somebody gets to 4 or 5 and then Christmas break comes, they give up. Now I've had people come in back after Christmas and do it. Because let's face it, we got to be able to do derivatives. I mean, everything we do the rest of the year, you've got to be able to do derivatives. And that's what this is. So, I mean, this is a pretty key thing. That's why we're not going to do just one quiz on it and go away. Right? You got to keep trying to do it because you want to do this. And this is pretty typical. Most college calc courses do a gateway test like this. And that's where I got the idea. And where you have to do it repeatedly.
Is it no calculator?
Okay? Yes. You and Cole McConnell, he asked the same question. Right? Since our calculators will do derivatives for you, it is going to be no calculator. All right. So, Cody, you're up. Type in, type in the derivative of, let's do that first one. So, where's derivative? Now, while he's finding it, that's next to the 9. That's good. I'm glad Cody's the presenter here, so that shows when we're practicing for this, it's good to use your calculator as kind of an electronic solutions manual. So put an X there, because we're going to do this with X's. And then, now what was it? X cubed minus 2x what? To the 4th. So x cubed minus 2x to the 4th. Hit enter. And there it is, right? So big deal. What's significant about this? What's significant is, go ahead and type the second one, Cody, while I'm talking. What's significant is that when you add or subtract 2 functions, we know, because we have a rule, we wrote about this, is that we can do their individual derivatives. You can do the derivative of the first, do the derivative of the second, and you just get it. So now, what was the next one? It was x cubed. You didn't write it down? Oh. Well, that's one way to go. Okay, x cubed plus sine x. And hit enter. And this is another thing you got to be prepared for. Sometimes a calculator kind of messes the order up, that writes it. It has it's programmed some way for some reasoning why it's writing in that order. We wouldn't write it that way. We would have written 3x squared plus cosine. So you got to be aware of that when you're using the calculator to check your own work when you're practicing these. Okay? All right. Now, the next one. Okay, now don't hit enter on this one yet, Cody. Now, so here's what our dilemma is right now. So what we're wondering is, what happens if I multiply two functions? Can I just do their individual derivatives like we just got done doing up here? Well, if we could, the derivative of x cubed would be 3x squared, and the derivative of 2x to the fourth would be 8x, and when we multiply those together, we get 24x cubed, right? But we know that's not right. Because if you multiply these, what?
8x cubed.
Oh, yeah. Well, we know it's not right for a lot of reasons. And so this would be 8x to the, like I said, 20. So this would be 24x to the fifth, right? So 3x squared times 8x cubed. Oh, and by the way, I'm glad I did that. Because that is another, and this is going to drive, what drives me nuts, but it's really going to drive you nuts. When you get a problem like that, where you bring the power down like that, and you just forget because you're thinking about the next step, and you forget to drop the power by one. That's what I did there. I brought the power down and just forgot about the third. I saw that on our last quiz on one of those where we had a deal like that we had to do. So you got to just be really careful about those things because you hate to miss one just because of a silly mistake like that. All right. So we're thinking if that's the case, if we could do each one of these individually, this would be our answer. Well, but we also know we could just multiply these together, right? And get 2x to the 7. And what's the derivative of that? 14x to the 6. So there's no way the answer can be 24x to the 5th. So go ahead and hit enter now. And so obviously that doesn't work. It doesn't work when we're multiplying two functions. It doesn't work to do their individual derivatives. Okay, Cody, go ahead and type the last one. And so since we've just learned that, okay, this doesn't work, now we're going to do x cubed times sine x. Whoops, careful. No, you're still up in the exponent. There we go. So now we're going to do x cubed times sine x. Now, if things were going to really work nice for us, this would have been 3x squared cosine x. That's what it would have been. But go ahead and hit enter. It's not. And we just saw it last problem. It's not. This is what it is. The calculator knows. Now, it did actually write this in reverse order from the way I would want to write it. So I'm going to go ahead and put that, I'm going to switch these around. And while I'm doing that, be looking at this and see if you see what the rule is. See if you can figure out what the calculator, here's how we would write it. Now it's plus, so it doesn't really matter. But you'll see why it's kind of important. So look at that blue thing. Can you tell what the rule is? It looks like it did the derivative of the first one. And it left the other one alone, right? It's kind of like taking turns, right? It's kind of like it took turns. It said, I'm going to do this derivative and then leave that part alone and leave it on there. Then I'm going to put a plus sign, and then I'm going to leave that one alone and then do the derivative of that one. And that's exactly what the rule is. That's exactly what the rule is. It's called the product rule. So in our notes, so we wrote that down. Okay, so let's go to this. And this is called the product rule for derivatives. And what it says, I'm going to write it two different ways. I'm going to write it one using our regular old function notation, because you're going to need this in your homework on a problem. I'm going to show you an example of that here in a minute. So you guys tell me, what would I write for the rule? F prime of x times g of x. And let's just keep it in this order, but you're right. I could switch those around. I'm going to go f of x times, and then g prime. That's just kind of how it's usually written, but you're right. Since we're adding, the order doesn't matter. Since we're multiplying each of those things, you can flip them, that'd be fine. But that's what the rule says. Okay? Now, the way we usually write it is using u's and v's. Now, what's different? U's and v's, f's and g's? Nothing really. Nothing really. When we do it with u's and v's, we tend to leave off the x's. right? But it's important to understand that it is still with respect to x. Now, we're going to talk about that here in a minute. But it's important to understand that this really is u of x and v of x. But for some reason, over the years, books have always just used u and v when it does these derivative rules. So we're going to use it too. All right? So here's how we'll usually write it. U prime v plus uv prime. And it's just kind of a quick, easy way to remember. U prime v plus uv prime. U prime v plus uv prime. Now there's other, we're going to do the quotient rule with division, and you'll see why it's kind of important to write it in this order. If you remember it in this order, it kind of helps. Okay? All right. So these are the same thing. These two are the same thing. All right. Now, let's do, I want to talk about this just a minute, this whole dx thing on the bottom. It's important. We haven't emphasized it, but now we really need to. This means with respect to x. It means that's the input variable. Now, Cody, back to the calculator. This is the last thing we'll do on the calculator. Well, it's not quite the last thing, but go ahead and type in the derivative. Go ahead and get the derivative thing again. Okay, put an x on the bottom, and then do x squared, and hit enter. And of course, the derivative is 2x. Now do the same thing, except use t's this time. Okay? Okay? And the derivative is 2t, right? It's not surprising. The derivative with respect to t of t squared is 2t. So we can change, it doesn't have to be x's, it could be any letter we want. Okay, one more time, Cody. This time put t in the bottom, but put x squared in there, and don't hit enter yet. Okay, anybody want to guess what's going to happen when we tell the calculator to do this derivative? An error. Might get an error, right? Hit enter. Okay? Now here's what the calculator is doing. The calculator is saying, okay, we're going to do the derivative with respect to t, which means t is the variable. Everything else is constant, like a k. That's how it, like we use k for a constant, and the problem that has x's, x is variable, means it can change, the k is constant. So what the calculator is doing is saying, okay, everything else is constant, so this is a derivative of a constant, derivative of constant is 0. Okay? So, go ahead and grab that same thing, go ahead and grab it this time, it'll actually be faster. And now tack on a times t after the square. Down there, right there. Okay, now, yeah, right there. Now, don't hit enter. What's the answer to this going to be? X squared. Because this is like 7t. The derivative of 7t is 7. Right? Go ahead and hit enter. Okay? See? So, because that's the key part of that was that t on the bottom, the dt. Told you that t is the variable. Everything else is treated as a constant. All right. So, that notation is important. All right. So, let's do a couple of quick example problems. Here's just a routine one. Y equals sine 2x times e to the 4x. Okay, you guys find y prime. I'll give you a couple minutes to do that. Shouldn't take more than that. Now, in the gateway test, we got 10 questions. They're probably kind of a somewhat even split between easy, medium, and hard. Problem is, what does that mean? I wouldn't spend a lot of time worrying about it, but I would categorize this. This is pretty easy. But we got a whole week of study, so it might not seem easy right now. By the time we get to next Tuesday, this will be pretty easy. The only thing making it a little harder than an easy with those numbers on the inside, but that really shouldn't be much of an issue. Okay? So here we go. So one of the things, if you haven't gotten it yet, go ahead and keep finishing. But you recognize this as a product. It's one function times another. This is like your u and your v. You might even write that down, whatever. Product rule says the derivative of the first. What's the derivative of this? You got to kick out a 2, don't you? 2 cosine 2x. And what do you do with this? Leave it alone. Plus, we leave that alone. E to the 4x and you got to kick out a 4. You don't have a 4, you missed it. That's one of your 2 that you can miss, right? That's one of your 2 that you can miss just because you left off that 4. Now, how are you going to write them? That's the other thing. With algebra, some of the mistakes you're going to make are going to be algebra, not put parentheses in where you need parentheses, those kind of things. Okay, we're going to talk a lot about this as the week goes along. One of the things I would tell you is if you're just rearranging, then it's not important. You don't have to do it. So to me, putting this 4 would be best out here. So it'd be best to write this 4 sine 2x e to the 4x. But you don't have to. The other answer you had there is fine, right? Just rearranging is not that important. But the problem we run into sometimes is the thing we're tacking on might need parentheses around it. We forget to put parentheses around it. Well, then you do lose points. Okay? So just rearranging is not important, but you know what? If there'd have been a 3 in front of here, let me put it in blue. If there'd have been a 3 in front of here, then putting this 4 together with the 3 to get 12, that you would have to do. Because that's not just rearranging, that's simplifying and putting stuff together. So it's just rearranging, don't worry about it, but if you can put things together, you should. The last thing I will mention is factoring. Some of you might look at this and say, hey, there's an e to the 4x in both of those. I can take out an e to the 4x. You're right, but then you can't do anything else with it, so don't bother. Okay? What do we usually factor for when we're simplifying? We factor so we can cancel, right? We factor and then cancel. So if there is something you can factor out and then cancel, then you should do it. But in this case, we're just factoring out and just leaving it. So that's just kind of rearranging in my mind. So I don't think that's important. Now, if you do it, that's fine, but I'm just saying why do it? Because then if you factor it wrong, and then that's your answer, then you're gonna miss it. You had it right, and then you went and did something else, and then you screwed it up. Okay? So you got to learn when to do those things and then to do them right. All right? Okay, so that's a product rule problem. You're going to have some opportunities to practice multiple ones of those. Okay, here's another one that I want to do, because this is like what's going to be on, you're going to see on the homework. Okay, you're going to be given a function h of x, so write this down. You're going to be given this, and then in the directions, well, I think in this particular problem, I think they actually give you a table of these values. But I'm just going to write some of them down here. They give you f of 2 is -1, and they give you g of 2 is 7, and they give you f prime of 2 is 3, and g prime of 2 is -2, or something like that. They give you this whole group of values. Like I said, in the homework, I think they give you a table with all these values. Okay? And then they ask you this question, or something like it. They ask you for h prime of 2. So what do you need to do? You need to find h prime of x, right? And you'll hear me say this many times. I've already said it many times this year. If you want to find h prime of 2, first find h prime of x, and then you can plug the 2 in for the x. So we need to find h prime of x. Well, that's just the product. We just wrote it on the other page. So it'd be f prime of x times g of x left alone plus f of x left alone times g prime of x. Now here's where some people get lazy and don't want to write this all out, and they can really run into trouble when they're plugging numbers in. Okay? If I want to do h prime of 2, I first write down h prime of x, and now I just stick a 2 in every x. And I'm going to write it down. Right? And now it's just a matter of plugging in stuff. So f prime of 2, I go over here on your homework. I think you'll look it up in a table. So f prime of 2 is 3. G of 2 is 7. F of 2 is -1. G prime of 2 is -2. We get 21 plus 2. I think I did that right. You get 23. That's h prime of 2. We don't even know what the f function looks like, the g function looks like, the h function looks like. All we know are what their equations are. We just know these values. So this is something you often see. Actually, what you probably more often see, instead of just asking what's h prime of 2, they often do this. They'll give you this function h, They'll give you these values, and they'll say, is H increasing at 2? Well, what's it mean? Is H increasing at 2 means, don't say it, is H prime positive at 2? Well, how do you tell you find H prime at 2? So we go through all these steps. Oh, it's positive. So you'd answer the question, yes, H is increasing at 2 because H prime is positive at 2. So you use the chart and that kind of thing. So it connects back to the stuff we learned in chapter 1 and chapter 2 with the chart. Okay? All right, so there'll be some of those kinds of things using the product rule on the homework. Okay, now let's talk about the quotient rule. Okay? The quotient rule. And this is what we're going to go back to that Washington midterm, and we're going to do that example there. Here's what the quotient rule says, and we're going to just use the U and V notation just to shortcut this. We could do it with f of x and g of x, be the same. It's just messier with all those x's. But I think on the homework they give you one like the one we just did with f of x divided by g of x, and so you write it out. But normally we're going to see u divided by v. All right, so Cody, you're up for one more thing here. All right, so let's do our derivative with respect to x. Now again, the calculator is going to do this backwards. So let's do x divided by sine x. Okay, and hit enter. Now, I'm going to go ahead and rewrite what the calculator did here because it factored out a negative and then flipped it around from the order I would do it. So I'm going to distribute this negative back through there, which would turn this positive and flip it around. So actually the sign would be positive. I'm going to put a 1 in front of that. You'll see why in a minute. Maybe you see it already. And then this one would be negative. So let's just look at the top here. So the top would be that. So can you see where the top came from? That's how you guys would do it if you're working it by hand. You would get that. Yeah, where'd the 1 come from? Derivative of the top. Leave the bottom alone. See the take turns thing again? This time it's a minus thing, right? It's quotient rule has a minus in it. Product rule has a plus. And then it's the x left alone, and then the derivative of the bottom, right? So it's just like product rule was, except it's got a minus. And instead of the first thing and the second thing, like it was a product, it's the top thing and the bottom. And then what's on the bottom? The bottom square. The bottom square. So our rule is u prime v minus uv prime over v squared. That is the quotient rule. Now, when I was in high school, my calc teacher had a little bit of a sense of humor. Kind of like things like this. And for some reason, this stuck with me, so I'm going to show it to you. This was in Hebron, Nebraska, the Hebron Fighting Bears. They don't even exist anymore. They're now the Thayer Central something stupid. But anyway, so high is up high, ho is down low. That's how you remember that. And this is how he wrote, this is how he would write this. So he kind of flipped these around because it just sounds better. So the V is the bottom left alone, so he wrote ho, and then the derivative of the top, right? U prime is the derivative of the top, so he wrote a little d for derivative, like that, minus, and then the, what's that? The top, which would be high, times the derivative of the bottom, over the bottom squared. So this is how I learned. Ho-de high minus high-de ho over ho-ho. I promise, that's how and I only tell you guys this. I only tell you this so that you don't think I'm crazy when I'm doing, because sometimes when I'm doing quotient rule problems, especially if they get a little tricky, and I'll be saying this to myself. I'll say ho-de high, high-de ho, and you'll be, what does he say? Ho-de high minus high-de. This is what I'm saying. But I think over time, I've found that most people just prefer to memorize it. That's fine. So you won't hurt my feelings if you don't do the ho-de high minus high-de ho thing. All right? And I think it just fits nicely with the product rule. So you'll memorize the product rule this way. All you got to do is put a minus sign in there, right? Do that. But there's another option if you want to do it. All right. So let's go back. Let's finish this up here and go back to this Washington midterm. And what we were supposed to do is find the instantaneous velocity at pi. Well, what that means is a derivative. So we would want to do the derivative of this. So our u is the top, v is the bottom. So d prime of t would be what? Let's go through it. What's it start with? Z, thank you. The u prime v minus uv prime, right? Derivative of the top is 0, right? The derivative of 100 is 0. Times the bottom left alone, which really isn't going to matter because it's times by 0. Minus the top left alone. Now, here's a place where people are going to mess up. This is I'm going to try to point out places where the gateway test, where people are going to get caught up on the gateway test and miss things. Right here, when we're minusing on the quotient rule, means there's a lot of times a distributive that has to happen. And parentheses become really key. And right here, I'm about to take 100 times the derivative of the bottom. Now, it turns out I don't need them, but oftentimes when you do the derivative of the bottom, you have some plus signs in there. You have multiple terms. You have to put those in parentheses because you have to take that all times 100. Now, it turns out the derivative of the bottom is what? Just 4 cosine. So we wouldn't really need parentheses there. We could just write 400 cosine. But a lot of times there would be plus signs there. Those parentheses would be necessary. So be aware of that. And then the bottom squared. 5 plus 4 sine of t all squared. Now, we're supposed to do the derivative when t is equal to pi. So we plug it in. Right? But that's our derivative. Now, this whole thing is 0, so that doesn't matter. Cosine of pi, no, negative 1 times 4 is negative 4 times negative 100. So that's positive 400. Sine of pi, 0 times 4 is 0 plus 5 is 5. 5 squared is 25. 400 divided by 25, 16. So there is the instantaneous velocity of t equals pi seconds. The next question, if you remember down there, was, is the particle moving to the left or to the right? It's moving to the right because the velocity is positive. And then the last part of it was, give all the values when it's moving to the right and to the left. Well, that's where you do a number line. You do your derivative and set it equal to 0. Now, we're not going to get into that right now, but basically a fraction is 0 whenever the top is 0. So we would want to check and see when the top of this would be 0. Those would be our stationary points, do a number line, and then we can tell when it's going to the right and when it's going to the left. So anyway, that kind of finishes up that midterm thing we were talking about, but that's where we would use a quotient rule. Now, we said we could also bring this up and make it the negative 1 power, but that's when you have a function inside of a function, and that's what we're going to deal with tomorrow. So if you think about what we've learned, last chapter we learned all the derivatives of all the different types of functions. Trig functions, exponential, log, power rule, all those kinds of functions. The only ones we haven't learned yet are the inverse trig, like arc sine, arc cosine. Those are coming later in the week. We just have a couple of those. Now what we've just learned is we can take any of those functions and multiply them together or divide them. And we can find that derivative using the product and quotient rules. The only thing we haven't figured out then, and this is tomorrow, is what happens when you have one of those functions inside one of those functions. Like sine of x squared. How do we do that? And that's what we'll do tomorrow. Okay, so your homework is, I handed out that assignment sheet, so get that assignment sheet out that I passed out. Everybody get one? Cody, did you get one? I think I put one on your desk. Okay, so our homework is going to be that first one there, section 3.1. Now, I do want to show you, not my fantasy football team. But yeah, but I got rid of it.
You gotta-
I scored 148, and I still got one guy left to play, and I'm number one in the league. So whatever. But anyway, um, 9-4. It will be after. But anyway, now on our Google on our class website here, okay, on our class website, under the web links, which is down the far left-hand side, okay, it says derivative practice 1, derivative practice 2. So as we go through the week, okay, we're going to have homework, book assignments, but we'll also have opportunities on the website for extra practice. Now, we'll do some practice in class. I'll throw out some, have you work on them and so forth. But we are cut back on time a little bit the next 3 days this week, so that'll cut into probably just a little bit of your in-class practice time. So I'll go ahead and still have time to answer questions, work some out with you and so forth. But some of this practice will be not your homework, but get on this website and practice. It'll be time well spent as we go through the week leading to next Tuesday. By far, your best scenario is pass it the first time. Not just because of the grade you could get for it, but then you don't have to mess with coming back and doing it again. And even then, because you're not all going to pass it the first time. I'd be great if everybody does. That'd be awesome. But at least if you really work hard between now and next Tuesday and you don't pass it, at least you're probably in pretty good shape to pass it the second or the third time. Once you see what you missed and what went wrong and so forth, then people tend to do pretty well in the second, the third. But if you haven't practiced much and you barely get a few right on the first one, it gets really tough because you got to keep up with all the new stuff. So, I mean, you just really got to practice it. So I want to show you these websites I got here. Yeah.
If we all get it right
Is it-
first time, we would be dead.
All right. So on, I don't know. Yes. If everybody in both classes pass on the first time, we can have 7 movie days. We'll have 7 movie days. That's how confident I am that not everybody will. Okay. We'll have 5 movie days a week, all of term 2. I might. I had my fingers crossed. All right. All right. There were 2 links there. One, this one says derivative practice. Oh yeah, I recorded. I recorded. Okay. I take that back. That was all right. So on derivative practice number 2 is just some PDFs of some derivatives. They're from Arizona State. And again, they have the same kind of gateway test kind of thing. And so they've got some practice tests with some problems. And we'll go through one of the days here later in the week. I'll show you those. And they kind of go in order by certain things. You get easier, get a little harder, and so forth. You get into some product rules, quotient rules, stuff like that. Okay? Another one here, the number 1 here, derivative practice number 1, is it just pulls up a bunch of different problems. Now, you can get different levels. Yeah, you can get 1, 2, 3, 4, and quite nasty. Now, I would say probably stick with the first 3 levels.
White, I just like it.
I mean, quite nasty.
Never.
Well, it has a function inside of a negative 2.2 power function, which is inside of a square root function, which is n squared. Of course, square root squared wouldn't be that big a deal. Let's do another one. But you just get some things that we would not get into, okay, which are just kind of silly, quite honestly. This one is not that tough because x squared, this is one of the things I want to talk about on your homework. Oftentimes, before you do a derivative rule, you should see if you can just simplify it a little bit first. Well, for example, square root of x. Before you do the derivative, you got to do what? Make it x to the 1/2, right? So you can do a power rule. So you often have to rewrite them so you can apply your rules. Well, here, what's x squared times x to the negative 2? X to the 0, which is 1. So really, this is just cosine over e to the x, which is a very basic quotient rule. So to me, that's more of a level 2. Right, because it's a quotient rule, maybe even a level 1. Okay, so that one wasn't very hard. This one would be not that bad. It's got natural log, which we just cancel. But what it does have is a product rule down on the bottom. So let's pretend the logs cancel. It's got a product rule down at the bottom, and then it's a quotient rule. So you have a combination of these rules, which we could get into those. So that one, but I think you'll see plenty of those if you just stick with level 3 as more of your hard ones. Now this has a function inside of a function which we won't learn until tomorrow. So I wouldn't get on this website yet. I'm just kind of showing it to you. But what I like about the website is if you want some practice on these, like these a to the x ones, or the log of different bases, you can just practice those. Or if you want to practice just your trig ones, you can just do some trig ones. Okay, these ones on the bottom row with the h's at the end, we're not going to get into those. So we don't do any of those. And the inverse trig ones we're going to be doing at the end of the week. Okay? All right, so I just show you those for that reason. All right, let's take a look at your homework now. Go ahead and open your book to page 166 real quick. We just have a few minutes left, and then this will be our best, probably our best use of time. So on page 166, your very first problem, number 9. Somebody got that? What's it say? Y equals x times x to the negative 1. Is that what it is right there? Okay. Now the directions say, now there is one set of directions I want you to ignore, and that's when you get to some of the later problems. It says find f prime, and then check the graph to see if it's reasonable. Don't worry about the graph. Okay, we're not doing anything with graphs. We're just doing the rules here. Okay, finding these rules. Don't worry about the graph. But on these first couple sets of directions, it says do this 2 ways. Do it one way with the product rule, and then do it again, except simplify it first. And this is what I was just talking about. Sometimes when you get a function, you can simplify it first before you do the derivative. Well, that's definitely what we would want to do on this one. So I'm going to do that part first. I'm going to do the second part first. So let's simplify this. So what's x times x to the negative 1? That's just 1. So now here, I want to talk about this notation again. Because on the quiz, it was driving me nuts. And some of you lost some points on improper notation. So this is why I didn't do a derivative yet. All I did was simplify this. It's x to the 0 power, which is 1. Now what's the derivative then? 0, right? So you're done. So clearly that's what you'd want to do in this one. But the directions want you to do it with the product rule also, just to see that it gives you the same thing. So over here, now I'm going to label this y prime, because I'm about to do the derivative. I'm going to do the product rule. So it's got to be labeled y prime at this point. So we do the derivative of the first, which would be 1. We leave the x to the negative 1 alone, plus we leave the x alone, and now I'm going to put this in parentheses. We do the derivative of that. What's the derivative of x to the negative 1? Negative 1 x to the negative 2. Now, let's work with this. Let's simplify this. This would be 1 over x. And what would this be? This would be, well, here's the way I would think about it. You could think about adding the powers, I guess. I would think about putting this x down on the bottom since it's a negative power. So I would look at the negative 1x on top, and I'd have an x squared on the bottom. Now, I could have added those powers. What happens to those x's? This one cancels one of those x's, right? And we get 1 over x plus negative 1 over x, which is 0. Oh, okay, yeah, it worked, which we knew it should. But, so I want you to go through that like they said, because number one, it's good practice on the product rule. But it also showing you that, hey, on some of these, you wouldn't even do the product rule problem. You would just simplify it first, and then you would do the derivative. But it should work out the same either way you do it. All right, so that's the first part of your homework. Then it gives you a bunch of others where you do that. And then there's some where you have the table that I was talking about, where you have that f of x and g of x, and you use the rule there. Okay? So do a good job on the homework. If you have questions, come in and see me in the morning, because of the shortened time we have, we're probably not going to spend a great deal of time going over stuff tomorrow, for sure. Because I think these are pretty straightforward. So if you are having difficulty, come in and see me. Okay? Because, man, if if we don't do basic product rule ones, that just makes it really tough when we get to the gateway test, so. Cody, you got that? Oh, yeah. That's fine, you can come in. No, come in after school and tell somebody,
Alright.
just tell Mrs. Payne or whatever, somebody, some teacher there. They'll write it down. Yeah, maybe, I don't know if you can pay Mrs. Payne.
Drew Small or Jimmy Johnson?
Was, really?
Yeah.
Oh, well, maybe.
So who do you times the 1/3 x would be
What are you doing here now? So you did the derivative first, and then be times that left alone. So it's just time.
this isn't product rule, this is just a simplified.
Well, you called it y prime. You labeled it y prime.
Yeah, because I'm doing
Renee, you can't.
once you the simplified.
You simplified it in your head?
That was fast, Renee. You don't have a class.
That's
Well, you
why,
don't have to
that's,
walk versus you out there, he's already done.
that's why I simplified or whatever.
No, that's not simplified, because what's x to the 1/2 times x to the 1/2?
Oh, that's just how you did it?
Yeah, that's what I mean, is simplify it as much as you can. Writing the square root as 1/2 power is not simplifying, that's just rewriting.
No, it's
So,
not.
so what, that would be,
But I have natural
that'll just be y equals x, right?
That'd be y, so we don't, there's no y prime
But I also have natural.
Oh, okay.
for the simplify?
Right, yeah,
Yeah, that's what I mean.
right here. We simplified it first,
Yeah.
but that's y. That,
Yeah,
because that's still
what
y.
I did. Yeah, that's what I got.
Right, but you haven't simplified it all the way.
Oh.
See, what I did is I added those powers together,
So this
and
would
I get
be,
1.
so this would be x to the 1.
They do computer software for like.
The 1, x to the 1.
like hospitals.
1/2 plus 1/2.
And they hired
That's
Disney
1/3.
to come and design the place, so.
So what's
God,
awesome?
you see, that's 1. Oh, okay, so that's x to the 5/6. It'd be 3/6 plus 2/6.
Oh,
You gotta get a common denominator when you add fractions.
and then you do it from there.
Then, so that's
Then you
y.
just do the regular.
Then you do the
power.
regular power rule, right. That's the simplifying.
So you can go over that stuff with me then, that I'm gonna miss tomorrow.
Best part about Thanksgiving break.
Oh, yeah, we'll have to do that tomorrow, or tonight, maybe.
I can't, I
You don't have time tonight?
well, I've
'Cause
got
you have
all
both.
this homework, plus, I don't get home till 6:30, I got this, all this homework, and then.
If you don't have bowling tomorrow night?
Yeah, I do. And then I have to get ready for the interview. So.
Okay, so tomorrow night would be better. So we can go over it tomorrow.
This might be a lot to ask for, but I just want to make sure I have all this stuff like